Good afternoon, guys. So here we are today to solve a problem on lake water hydrology. So this belongs to the module 1 of the course Water Resources Management with the subject code 17 CV 661. Let us have a readout of the problem. A lake has a water surface elevation of 103.2 meters above the datum at the beginning of a certain month. In that month, the lake received an average inflow of 6 meter cube per second from the surface runoff sources. In the same period, the outflow from the lake had an average value of 6.5 meter cube per second. Further, in that month, the lake received a rainfall of 145 mm and the evaporation of lake surface was estimated as 61 mm. Write the water budget equation for the lake and calculate water surface elevation of the lake at the end of the month. The average lake surface area can be taken as 5000 hectares. Assume that there is no contribution to and from groundwater storage. So let us solve this problem from this model question paper, guys. So before we solve the problem, can we just have a just small drawing which will help us to understand the problem better. So here we have to understand the lake environment first, because unless we understand the lake environment, we are not going to understand the runoff sources, the outflow sources from the lake or towards the lake. So I'm just drawing a simple drawing. So a lake can be located anywhere at the valley portion of hills, and the rainfall falling on the ridge lines, it can just contribute as inflow of the lake. Also, the water going outside the lake can be considered as many parameters such as irrigation for agriculture fields, or domestic purposes. So this can be termed as outflow volume, and the water coming from the ridge lines can be taken as inflow volume. So there is also a contribution of precipitation. That means if we just read out the fourth sentence of this problem, it says that further in that month the lake received a rainfall of 145 mm. That means this environment, this lake environment, also has a contribution of precipitation. And there is also a withdrawal of water in the form of evaporation of 61 mm. So there is also a impact of evaporation from the lake. So let us just put on the data that is available from this problem. So the inflow volume is being mentioned as 6 meter cube per second. Inflow volume is 6 meter cube per second. So inflow volume is 6 meter cube per second, whereas outflow volume is given as 6.5 meter cube per second. The precipitation is 145 mm and evaporation is 61 mm. So I'll just write it here. Precipitation is 145 mm and evaporation is 61 mm. So this happens, guys, in such a way that the water surface elevation, it depends upon these factors. That means the factors such as inflow volume coming as runoff from the ridgelines of hills and precipitation will add up to the increase in elevation of the water surface in the lake. Correct, no? So I'll also write the current water surface elevation, which is nothing but 103.2 meters above datum. Okay, so there is also an influence of evaporation of 61 mm and also an outflow volume of 6.5 meter cube per second. But the problem states that we have to calculate the lake surface elevation at the end of the month. Whereas the data which is being given or provided in this problem is pertaining to start of the month, which means that the duration of the calculation should be over 30 days. Correct, no? That is 1 month or 30 days. So we have to calculate the water surface elevation after a month. That means after a period of 30 days. So actually we are going to calculate, the change in water surface elevation, and the change in water surface elevation is nothing but change in depth of lake. Correct, no? Change in depth of lake. But if you just observe, whatever the data is given in terms of inflow volume is in meter cube per second with respect to inflow as well as with respect to outflow also. But we have precipitation and evaporation in terms of depth. But what we are supposed to calculate? We are supposed to calculate the lake surface elevation at the end of the month. So what is the unit for elevation? It is meters. That means we have to calculate the change in depth of the lake. Correct, which should be in meters itself. Correct, no? So basically what we are supposed to do, we are supposed to put up a water budget equation first. So water budget equation for this condition, which says that we have to calculate the change in depth of the lake. So in that sense, we have to just analyze and look upon that what will affect the change in depth of the lake. So change in depth of the lake depends upon water contributing into the lake. Okay, minus water withdrawn from the lake. So it will give you change in depth of the lake. Okay, now what is the water contributing into the lake? So whatever comes into the system input, as an input, is water contributing into the lake. So whatever leaving outside the system from the lake is water withdrawn from the lake. That means inflow volume and precipitation is nothing but water contributing into the lake, and outflow volume and evaporation is nothing but water withdrawn from the lake. So let us put it up like this. So it is inflow volume plus precipitation minus outflow volume plus evaporation will give us the desired result of change in depth of the lake. So this basically inflow volume is not with respect to depth, correct? No, it is with respect to meter cube per second, and outflow volume is also in terms of meter cube per second. So what we are supposed to do? So we are supposed to convert meter cube per second into meters. So how we are going to convert? So we are going to multiply it by time and divide it by area. So that is, this 6 meter cube per second is multiplied by 30 days equivalent of seconds. So what is 30 days equivalent of seconds? So 30-day equivalent of seconds is 30 into 24 hours into 60 minutes into 60 seconds. It is nothing but 2592,000. So it is 2592,000 seconds. Okay. So we have to multiply 6 meter cube per second by 2592,000 seconds. So this will get cancelled, right? So we have to divide it by area. So what is the area? Area of the lake. So area of the lake is 5,000 hectares. It is nothing but 5,000 into 10,000 meter square. So we have to divide it by 5,000 into 10,000 meter square. So this meter square and meter cube will get this cube will get cancelled, and where we will be left with in terms of meters. The same way we have to also multiply the outflow volume, which is 6.5 meter cube per second into 2592,000 seconds, whole thing divided by 5,000 into 10,000 meter square. Get cancelled, second and second will get cancelled, and we will be left in terms of meters. So which is our desired result that we are looking upon, that is change in depth of lake. So let us calculate this, and let us see what will be the result that we will be arriving upon. But before that, we have to add precipitation with respect to this, that is plus. Precipitation is 145 mm. So converting 145 mm into meters will be 0.145 meters. So this is precipitation. So here it will become evaporation. Evaporation is 61 mm. So this will become 61 mm, this will become 0.061 meters. Okay, so inflow volume is nothing but this. Inflow volume is nothing but this one. Precipitation is 0.145 meters. Outflow volume is this one, and evaporation is 0.061 meters. So let us solve this. Let us see what will be the difference in these values that we'll get, which will be giving us the result of change in depth of lake. So it is 6 into 592,000 divided by we are getting 0.31104. 0.31104. This is the depth of inflow plus 0.145 is the precipitation. This is depth of inflow and precipitation minus of, let us solve this one, 0.5 into 2.5 whole thing divided by area. So this is giving 0.33696. 0.33696 plus 0.061. So this will give us the desired result, change in depth of lake. So let us solve this to check. So what is the change in depth of lake? So change in depth of lake is equal to, let us solve this equation, that is 0.31104 plus 0.145, this is 0.45604. So minus of 0.33696 plus of 0.061. So it is 0.05808 meters. So the change in depth of lake is 0.05808 meters. That means there has been an increase in the water surface elevation of the lake. So there has been an increase in the water surface elevation of the lake, because we are getting a positive answer. So we have to add it with respect to the water surface elevation of the value which is been given in the problem, which is tends to be 103.2 meters plus 0.05808 meters. So the current water surface elevation is equal to 103.258 meters. So this is the final answer. The takeaway from the problem is that by the end of 1 month, the lake surface elevation has increased from 103.2 meters to 103.258 meters above the datum.